So all of that just to take care of the navigation per region. Next, we are going to finally answer the first question that I tipped off, which is how do we create a dictionary for... So the structure is going to be accessing the region's dictionary, which from the map world has been inputted as this guy here, which is the dictionary variable that we're going to use to store the information. And it's going to be creating a new entry for its dictionary to hold the new region structure. So we're going to be doing this for every single region. Region is the vector 2i we generated from the position of the AAB mesh piece with its grid size. So that is going to be a vector 2i. So here we can create a lot of stuff, and this will depend on how you want to use regions. So here I'm creating a objects, and here object is defined as an integer because this belongs to the enumeration on the top here that I'm going to be using. And this I believe it's faster than using strings because these are integers. So this is the approach that I'm using for this operation here, to use integers to create the dictionary entries. And so this one is going to hold objects with their global position, so you can use to calculate a bunch of different stuff later. So the second one is we need a navigation node and the navigation baking group name, so we can access it later for the reason we want. So this is what I'm doing here. I'm storing the region navigation node reference. So the navigation node is going to be inside this node, but I want its reference to be linked inside the data information for this region node. So this is what I'm doing here, passing it along as a reference for that region data information dictionary. And lastly, only the navigation breaking group name. So this is the structure, and you can add anything you want inside of here to be used later. Next, this is how I create the debug information you see whenever I run my scene. So if I run it very quickly here, just to show you what a LED looks like, you can see these texts here. Each one of these texts is a label 3D text that I'm adding some information, like the region coordinates. You can see here 2, -1. So the center coordinate for this world is on here, 0, 0. And you can see how that looks like. So this is the region. Then here is 0, it belongs to the object, so there are no objects inside of this region. Then there is the reference to the navigation region 3D, which we created for this specifically region part. And next, the navigation group baking name, which is 0, 0, because the coordinates for this region is 0, 0. So this is how it looks like whenever you convert the vector 2i to a string, so you can use to bake objects from the same group what belongs on that region. And you can see what that looks like with negative values. You can see that the string added the negative numbers there as well. So that is what the name of the navigation region baking names is going to look like. So this label information here for the debug is created here, and I add the label 3D inside each single map mesh. I set its global position to be its map mesh AAB center, set its Y position to be 0, so I can see everything on the 0. I set some settings here for the label 3D, like auto-wrapping mode, the width of the text, the font size. No depth text because I want to see behind the terrains. So if for some reason I have the text floating behind it, I still want to see it on the debug. Later I just set its text to hold the region with the data information inside the region, which you saw on there on the debug. And later I create a new entry to be able to access this debug label later if I want to change the information I'm displaying. So I'm creating a new entry inside my data information, which is going to hold the debug label. And here's a reference to the enumeration, so it's another integer here. And I'm using this to assign the reference to my debug label. And that is how you can debug your regions. Next, I want, after this loop here, iterator has finished. So this is after we have iterated through every single map mesh. So we have created and generated everything. I want to clear its navigation mesh and disable its navigation. So I don't know about behind the scenes how Godot handles this, but I believe if we're not using, it doesn't hurt to simply disable that and clear its navigation mesh. That is basically what I'm doing there inside the code. You can see here that is what it looks like. I'm clear the navigation mesh, assign it to be no, and disable it. Next, I want to post-process to rebake all of the navigation meshes. So this answers the next question, which is how you can rebake navigation meshes. So this is how you are going to be rebaking it. You simply access the navigation region nodes and that temporary array that I created with navigation region nodes, that for every duplicate copy of the navigation region that I create for every single map mesh, I have added inside that temporary array, so I can at this moment ask it for a rebake. And this is a function native for this as of the object here. So you can see the navigation region 3D has a function called bake navigation mesh. And this is the only function you need to rebake the navigation mesh. This will be the same thing as asking for whenever you click this button, is going to regenerate the navigation mesh. So that's how you can rebake a navigation mesh. It's pretty simple. And it's going to rebake based on the parameters you passed on its navigation mesh. Because we are creating it based on groups, it's going to create every single one based on that. So something cool that, if you go back here for the code, that's everything I'm doing, and later I'm just return the map size. So if you want to see something nice, I'm going to make an await function here. So I'm accessing back the navigation region node and create a timer based on its tree and waiting for its signal to time out so I can continue rebake the navigation mesh. This is so you can debug how the navigation is being built. So if I do that and run the scene here, you're going to see how the navigation is being done for every single map piece here. And there seems to be something wrong here. I must have mistyped something. So this will be probably because of the return value. So I believe if I assign map size to something like vector2i, like 3232, so just I can test this. We can do this. I believe now this await function is going to work. This is giving conflicts with the return value. If I do that, I should be able to get it work as I want. So now my fog of war is going to be screwed, but what I want to show you is how the navigation is being rebuilt. You can see here, square patch is being generated as navigation is being baked. And you can see how that looks like. So it's accessing every single region node that we have duplicated, created, and ask for a rebake of its map parts. And this is what it looks like. So you can see that the part of Godot that's pretty cool is it's merging the navigation meshes automatically, and you can see that purple square line where they connect together. So your units can access them through the various parts. You can see how that looks like, so pretty cool stuff. Back the stuff that I was working and clear my comments here, my await. So everything on this function generates the regions we need to work it out. So then the next question is, how do you keep track of objects inside of those regions? So we have created a grid region system for every single piece. So if I select all of them, this is what it's going to look like from the top down. We have created per map mesh. So now begs the question, how do you keep track of objects? So the fastest way to do that, I realized it was, I have to save it so it updates my comments on the await timer there, so I don't give this error anymore. So I have a timer here that I'm using to do this. So you can see here I have a world ticker with holds 0.25 seconds, and it's going to be ticking my world map. So the way I'm doing this is having fixed states as enumeration values and having a tick count. Whenever I pass the maximum of tick counts, I'm going to be resetting my tick count back to 0. So that is how I'm operating fix here for the RTS map world. So whenever I run the timer and the timer ends, you can see here that I connect the word ticker timeout to a function called word tick, and this is going to be increase the count whenever that timer runs off. It's going to be doing a lot of different things. One of those is updating my fog of war system, but also I'm going to be matching my thick count number, and I'm going to be matching it with thick states, which is my enumerator here. And I'm going to be doing different things based on thick states. So that is pretty a fun way to do it. So one of the ways I'm doing here is some tests on how to get the fastest way to iterate through dynamic objects. So that is what that code is doing. The fog of war here by displaying it if it's allowed to be displayed, and also setting its grid position. So this is how I keep track of objects inside the grid position. We're going to be asking for the grid position of the objects currently. So let's say that an object is on the grid system right there. I want to first grab its grid position currently, and I'm going to be checking if I should be changing its grid position with this function here. So this is how I keep track of the objects inside the region. First I grab the old region, I access its object data, which is right there, and the object data is a simple storage point for my object, which represents my unit. So you can see here we have object data with a dictionary, and I'm creating here some tests as I'm doing. And you can see how I'm storing object attributes here for the time being. So there's some changes for Godot, and I'm hoping they arrive before I fully flesh out the system. But for now, this is how I'm doing it. And here is every single attribute for the unit. So that is how I am storing them. And I'm accessing its object data and grabbing a reference from its region grid position. So the grid position iterator I'm holding on its state. So I have another script that simply holds the enumeration that I'm going to be using later, also for object states, and one also for AI states. That is what I'm doing. So for the code for the map world here, to keep track of the grid position of a given object, accessing the region's world dictionary with the old region and telling it to erase that. Then later I am accessing the world dictionary for the regions, the current grid position from that object, and I'm assigning it its global 3D position. Also inside that object 3D, I am also adding that region position as well. So this is how you keep track of that object data inside the grid system. And if you remember, we are doing this for every single thick at my RTS world, ticks right here, whenever its tick count iterator matches the tick states processing dynamic objects. So I have a list for every single object that in my game that is dynamic, which basically means movable objects, and you can also set up this on different ways. So the dynamic object list is this guy right here, which is a variable, a dictionary variable inside my RTS world that's going to store the object 3D plus its global position. So this is all the information I need. The rest I can calculate using other modules and stuff. So that is how I am keeping track of the position of the objects inside the regions. So that is for the dynamic object. So let's say you want to update your regions, debug information with how many units you have inside of them. So I have a tick state for that, and I skipped it out here for this tutorial. So you can see I'm accessing every single region, which is a vector2i in world region dictionary keys. And I am simply accessing its label node, its text, and assigned the first which region it is. Region is grabbed from here. And I'm adding unit count as a string value. And finally, I'm just adding the world region dictionary with the region we are using, its objects.size array. So if you remember from the module RTS world where we generated the regions, I have a structure here called objects that we are inputting here information. Whenever the world ticks, I'm adding objects inside the list with this function here. So if we access this function that keeps track of the object's position, you can see it access the world regions dictionary, the region that belongs to, and I'm creating another reference for that object whenever it moves through another region. So that is how I'm adding objects inside the regions. So the way that works is whenever the defig happens, I'm going to be accessing each region and being updating its label text with that information. So now that this code has been enabled, I'm going to simply place back here what I had and comment out. You're going to see what that looks like for the project. And that is one of the ways you can use regions to calculate. So you can see here we have the region counts for every single grid size. And if I start moving units, you can see how that looks like. So for some reason you needed to keep track of unit counts. That is one of the ways you can do it. So it's pretty simple. Then as you can see, it's pretty nice and it works all right. So because we have a navigation region node per region, I can simply see that working in real time. Here you can see the counts being increased. But that is one of the applications you can use it. In this case, for whatever reason, if you needed to keep track of units inside a given region, that is one of the ways you can calculate. So pretty nice stuff. So the next question that I want to answer is, how do you get benefits from regions like mouse context updates? And let me show you a real application of how you can use regions to benefit you. So see that I have these units which are not hidden by the fog of war yet. I am working on this. So you can see that I have units that do not belong on the same faction. This faction is player 1, which is red, and this faction is player 2. You can see that whenever the mouse reaches them, I am changing the mouse icon position. So how I'm changing the mouse position is actually pretty simple as well. So let me go to my player interface code for the RTS right here. And on its process, on its physics process, I'm doing a couple of things. So something I have changed is I'm generating a raycast to the mouse per physics frame from the player interface. And if you remember, my FPS for the physics process, so I can improve performance for this project. So this is actually 30 FPS per second because we don't need the physics that much inside this project. I'm generating a grid position, which is the raycast from the map towards the mouse position. That is required because I want to first grab its region. So I check if the region has that given mouse position. Otherwise, if you place your mouse outside of the map, I don't want any errors. So that is how I'm filtering out errors if you have that region. We are accessing its region objects through the keys of that region. So the RTS world with its world regions dictionary based on the mouse grid position, I'm grabbing from the module RTS world function, which creates the grid from based on the vector 3 raycast coordinates of the mouse, which is from the vector 2, that is this final function. So the region we are creating here is being used to cycle between all the objects inside a region. And I'm going to do a lot of things here. First one is see that if I have a target, so if the region object is not empty, I'm cycling between every single object inside of that. And remember, this is happening every 30 frames per second. I'm grabbing its position on the viewport by unprojecting from the camera. And this is how you can grab the 3D position of the object and turn it to a 2D position. So then later I can cast if its distance is less than a given one. So I have created a variable to do that. So I have a module for the selection operations, which is the module RTS selection operations, and I have some constants defined here. I want for target mouse some distance and also for the selection of units to hold another distance. So the player interface code, whenever its physics process for each single object gets its distance to be less than that given constant, I'm going to be asking if that single object, if its faction belongs to the RTS world faction 1. So this is temporary code. I'm going to be making factions a variable inside the RTS world instead of a static reference like it's here from a module RTS world. You can see that I have here. This is the enumeration for factions. So this is not going to work properly because let's say you want to change information for factions, that needs to be just like the faction colors, part of a variable that we're going to be changing. So this is dynamic information, not static. That is code that I'm going to be changing later to working on. So if that is the case, if the faction is different from the player one, I'm going to simply change its icon by setting the variable mouse icon to another one. And same that I got a new target. So I'm selling the boolean as true. And after everything here, we're going to break because we found a target. So we're going to break that. And if we have objects inside a region, we're going to run the second part here, which is if we did not find a target, to return the mouse icon back to 0. So this now is how I'm changing the mouse after we are putting the mouse on a single region. And I'm asking for all the objects inside this region to iterate their 2D position against the mouse coordinates from 3D to 2D for every single 30 FPS. But why I want that many frames per second to hold that operation is because I want instantly. So the benefits of using regions is we do not have to iterate through the whole map, so we would have slowdowns in the game. Instead, what I'm doing is for every single region, I want this to happen instantly. So you can see that the icon change as soon as I pass the mouse on the enemy unit that has the distance to the mouse position less than ideal. So if you wanted, you could delay this operation, but I think because we are running only one, because player interface is only executing this once, it does not have any performance issues, thanks to the regions. So this is a real application of how we can use regions inside your RTS for the mouse context operations. And here, while I only change the mouse icon, you can change how units will behave against other units. So I plan to expand this as well. So now I'm going to answer another question that's somewhat unrelated to regions, but it can benefit you. How you can change mouse icons. So that is how I'm switching mouse icons, by only setting its variable. So this variable inside the player interface, it has a setGet method that is simply going to assign the new value it passes. So this is an integer, so it's going to assign it as a new value. And I'm going to run a function based on a module that I called mouse icon. And this is going to be used the integer you pass here on the mouse icon. So the module mouse icon is how I'm changing the mouse cursor, and it's very simple. I'm going to first be storing enumerations for every single integer that I want, and I'm going to be calling these for the player interface later. I'm accessing a constant variable here. I'm also define a constant here, which is going to hold all of my mouse icons, which is going to be preloaded here as a given enumeration value, so as an integer base. The function is being called on the setGet as this one, that is going to ask for the input, and this is the function from Godot that allows you to change icons, which is set custom mouse cursor. And you can see here what it does. And it's going to basically set a new image resource, ask for a shape and a hotspot. So the first one is the texture. The second one is which type of input it is. In this case, it's cursor arrow. And the third one is which is the hotspot. So the hotspot for this is mouse icons target 1. And the mouse icons, you can see here I have the preloaded texture, but also I have the second information for the hotspot, so we can use it here. So you can see the image here that I have, which is this UI element here. So it's a simple image with 32 by 32, so the middle hotspot is going to be 16. So that is where the mouse actually is going to click, where it's considered the hotspot for the mouse. That is 16 by 16. And this is how you can switch mouse cursors. Whenever I want, I'm simply going to go to my player interface and set this variable. The variable is going to set its value as a new value, and is going to call that module function to set its custom mouse icon to do all the work. So you can see how modules are very nice to isolating this type of information, and you don't have to worry about mouse icon code inside of this code. So that is pretty awesome. So I think that covers everything that I want to talk about on these parts regarding the map construction. So I'm sorry if I did not code this from scratch. You can see how this will become a bigger problem, because first I have to explain the concepts of what I'm building before you can understand it, so you can accompany the video. And secondly, imagine having to type everything back from scratch that I worked on the previous days, just for you to be following along. So I think that by explaining, answer a bunch of questions and hopefully helps you in building your own RTS. So there are some of you guys that wanted to know how to handle object attributes. I showed a little bit of work that I did with that. On the RTS unit, you can see how that looks like. So this ideally will be built from a data spreadsheet that you're going to create. And once imported, it's going to build everything here to module applications. And you can see here some of that work that I'm doing as well. So yeah, also some of you requested some help with AI states for units. So I did not finish that. I'm working on it. I'm currently using it to move the objects. So I have an object state and an AI state. So it's like a unit has what it can do and what it wants to do. I want those two things to be separate so I can program them as I like. And later I can split that out as well. So you can see here how that looks like for the RTS unit. And also I plan to do, if I want custom behavior, to create these from modules. So that is something I want to create as well. That's why I did not make a tutorial yet. Also, something I'm working on at the moment for the RTS world is by each physics process frame, I'm running a check for every single unit. So this is stuff that you're going to see on the next video. Should be pretty fun. So my main work continues here. I want to create combat with the units, and also I have to finish the fog of war system so I can help you guys on how that works. So currently I am trying to find a way to enable or disable units visibility based on either distance from the fog of war from a given unit, or by using this texture information as part of every single shader for the RTS world. So I don't know which one is going to be faster. I have to create some tests. So having said all of that, hopefully you were able to follow along and I helped you in some way to continue developing advanced systems for your RTS world. And the results will be on the video about updating the fog of war system. So this is stuff for another time. Hopefully you'll enjoy this series, and I'll see you on the next part.